This series of lectures will be on Section 3.2 in College Algebra and Context, Solving Quadratic Equations. We'll also cover a little information about factoring and complex numbers. First, let's review some rules about factoring. First thing you always look for in factoring is looking for a greatest common factor. Always do that first. If your polynomial has two terms, look, is it a difference squared? A squared minus b squared factors into a plus b times a minus b. If it is a sum of cubes, like a cubed plus b cubed, that factors into a plus b times the trinomial a squared minus ab plus b squared. A difference of cubes, a cubed minus b cubed, is similar. It factors into a minus b times a squared plus ab plus b squared. Continuing factors. If you have three terms, you always look, is it a perfect square trinomial? A squared plus 2ab plus b squared factors into a plus b, the quantity squared, which of course is the same as a plus b times a plus b. If you have a general quadratic that's not a perfect square in the form a squared plus a times x squared plus bx plus c, you can factor by grouping, which I'll go through some rules for. You can go guess and check, or another method you have previously learned. Factoring by grouping. You arrange the trinomial with the powers of x in descending order. You form the product of the second degree term and the constant term, the first and third terms. You determine if there are two factors of that product of the first and third terms that will add to the middle term with the correct sign. If there are no such factors, the trinomial cannot be factored into two binomials. You rewrite the middle term in step 1 as a sum of the two factors from step 3 and factor the four-term polynomial from step 4 by grouping. We also need to talk about an imaginary unit and complex numbers. The imaginary unit, I, is defined that I equals the square root of -1. Normally as you know, we cannot find the square root of a negative, so we take an I, the square root of -1 out, and then we can factor the positive number that leaves. A complex number, the number a plus bi, a and b are real numbers, is to be a complex number in standard form. The a is the real part, and the bi is the imaginary part of the number. If b equals 0, you just have a plus bi. If this is a 0, it's actually a real number. B does not equal 0. A plus bi is called an imaginary number. And if a equals 0, you have just a bi, and that's a pure imaginary number. An equation can be written in the form a times x squared plus bx plus c equals 0, where a is not equal 0, is called a quadratic equation, as we know. And if we're using the zero product property, if two real numbers, the product of two real numbers is 0, at least one of the numbers must be 0. That's the way we get 0. For two real numbers a and b, if the product a times b equals 0, then either a equals 0, b equals 0, or they both equal 0. That's the only way you can get 0 as a product. We use that zero product property to help us solve equations, and here's a solve equation right here. First, we're going to get in the form equal to 0. So 3 times x squared plus x will be -2 equals 0. We need to factor this into two binomial factors, and I'm going to do it by the grouping method. So first I'm going to take 3 times negative 2, coefficient of first term and the last term, multiply them together, I get negative 6. Then I ask myself, are there two numbers that can multiply together to give me negative 6 that have the sum of positive 1? So for 6 I can get 1 and 6, or 2 and 3. 2 and 3, if these signs were different, I could get negative 6. Actually, 3 and 2 are it. So I separate this middle term x. I'll keep a 3x squared. I separate that into a 3x minus a 2x. And still minus 2 equals 0. You can see that this, in place of the x, would still have the same value. And now I can take the first two terms and factor out the greatest common factor for those, which would be 3x. That would leave an x plus 1. And the last two terms, negative 2x minus 2, I could take a negative 2 out of both of those. That would leave an x plus 1 equal to 0. Notice that these two things in parentheses are both the same, and they need to be for this to continue. So we factor out that x plus 1. And what did that leave us? Well, from the first thing, we had a 3x times the x plus 1. And the second one, we had a negative 2 times the x plus 1. This then becomes the factored form of my original quadratic here equal to 0. Now, these two things multiply together to equal 0. The only way that happens is at least one of them equals 0. So either x plus 1 equals 0, or 3x minus 2 equals 0. Solving this, we'll find x equals negative 1 as a possible solution, or we have that 3x will equal 2, and so x equals 2/3. That's my other possible solution. Most quadratic equations have two solutions. They can sometimes have be the same two, but they have two solutions.